We're going to solve this following example using integration by partial fractions. Since the power in the denominator is squared and then squared, so 4 total and 3 on top, we can directly begin taking the integrand and breaking it into separate fractions. So it's already factored for us. Because it's a repeated quadratic factor in the denominator, we need to include all possible powers of that factor. Let's clean that up a little bit. So here we have x squared plus 1. Here we have x squared plus 1 all squared. If it was cubed, we'd then have cubed. We include all powers up to and including this one. In the numerator then, because this is quadratic, we need an unknown linear term, ax plus b, and here a different one, so cx plus d. As with all the partial fractions ones that we've done, we're going to multiply the entire thing by the denominator now. Well, that's going to give us 2r cubed equal to ax plus b multiplied by r squared plus 1 plus, when we multiply this by the denominator, the entire denominator cancels and we're just left with the numerator, which is cx plus d. Expanding these terms then, we get, and like you saw me do in class, I made the same mistake. I'm so used to doing it with x that I forgot that we're dealing with r here. So this is not x, this is r, and this is r, and this is r. Let's try that again. So ar plus b, cr plus d, cr, and r. There we go. So continuing, we multiply r cubed plus ar plus br squared plus b plus cr plus d. So 2r cubed then is equal to, we're going to collect all the similar terms together. So this is ar cubed, there's no more cube terms. Br squared, there's no more squared terms. Plus we have ar and cr, so that's going to be a plus cr. And then we have two constants, b plus d. Now we're going to equate the coefficients, so we're going to do it for each of the coefficients, cubed, squared, each of the variables, pardon me, r and the constant. So on the left, the r cubed coefficient is 2. On the right, the r cubed is a, so a equals 2. On the left, the r squared is 0. On the right, it's b, so b is 0. On the left, the r coefficient is 0. On the right, it's a plus c. We know a is 2. That tells us that c has to be minus 2. So we have 3 of the 4 already. The constant then on the left is 0, on the right is b plus d. We know that b is 0, that tells us then that d is also 0. There's all of our terms. We'll change colors here to do the integration. So the integral then, we'll take down here. will be 2r over r squared plus 1 dr plus integral of minus 2r over r squared plus 1 all squared dr. Integrating gives us 2, not 2. We're going to use u substitution, which gives us ln of r squared plus 1 minus, again, the same u substitution. U is equal to r squared plus 1. R squared plus 1 to the minus 1 over minus 1 plus a constant. The only simplifying we can do is make that a positive, so we'll just leave it like that. And that's the final answer for that one.